When we heard about the HIT challenge, we felt both intrigued and intimidated because of our modest experience in the field. We took it upon ourselves with great interest to imagine a home that could be beneficial to both the environment and its occupants. Our core concept was to create a house that could be self-sufficient while at the same time offering the possibility of control to its users.
We aimed at creating a system of predefined rules that the house would follow, which could allow the owner to easily set preferences to fit his or her needs and desires. For example, the user can set up the logic behind the autonomous heating and lighting that the house provides. We also wanted to create the possibility of controlling these preferences remotely from, for example, your smartphone or a web page that could easily be accessed from anywhere. But that's when we faced one of our biggest challenges yet. How could the house know when somebody's home?
So here is how it all works. We have placed the sensors around the house in such a way that would allow them to work in succession to confirm each other's readings. In case when someone enters, first is the distance sensor that we have placed above the door at an angle, which picks up two comparison points one after the other. When it first registers a value greater than 0, it remembers it as point A. Half a second later, the new distance becomes point B. The 2 points are then compared so the program can decide between one of two cases. If the distance to point A is greater than the distance to point B, the house knows that someone is walking in, and vice versa. If the distance to point A is smaller than the distance to point B, it means that the person is walking out. If the first case is detected, the program enters a cycle which waits for confirmation from the second sensor. We have placed the IR reflective near the door frame, so that when someone enters or exits through the front door, he would always cross its range. After the distance sensor reads case 1, the person has about 10 seconds to enter the range of the IR reflective. If he does, the program starts waiting for confirmation from the third sensor. We have placed the passive infrared in the next room because we wanted to prevent the chance of a false reading. The person walking in now has another 10-second window to activate the motion detector, and thus giving the SmartHouse the final confirmation it needs to know that someone has entered. And if the sensors are activated in the reverse order, it knows that someone has left.
So here it is in action. We have installed a few LEDs to indicate the various systems in the house. We will demonstrate how they become active when someone enters.
First, the person walks to the range of the distance sensor and the two comparison points get picked up. Then he crosses the IR reflective and finally trips off the motion detector. At this point, the house knows someone has entered and wakes up.
In light of the previous demo, we would also like to point out that counting the people inside the house gives way to numerous applications to the light and temperature sensor. Taking into consideration the high probability of a forgotten lamp when the owner has already left, we have devised a solution that will automatically switch off all lights inside the house when the person count reaches 0. Another mechanism takes control of the user's temperature preferences when he is not at home. What it does is it alters the given parameters so as to lower the heating system's values in order to save energy and therefore money.
SmartHouse makes use of its many different capabilities to provide various security and surveillance options, such as break-in and fire monitoring. In such cases, the house could automatically send signals to the fire department or police.
Now we'll explain the energy saving and signaling systems. We'd like to start off with the supported green mode. The SmartHouse automatically enters green mode when there is no longer anyone home. In this state, energy consumption is decreased to a minimum, all lights turn off, and the user set temperature is lowered by 5 degrees to reduce demand from the heating system. Next up is security and the signaling. In case of an emergency, the house can alert the authorities of a fire or a break-in. If the temperature rises above 60 degrees, the fire alarm is activated and an automatic signal could be sent to the fire department. The SmartHouse can also enter a mode we call lockdown. This state is manually declared by the user and is convenient when leaving home for an extended period of time. When in lockdown, The house considers any motion detected an entry, and any entry a break-in. If the person count becomes greater than 0, an automatic alert could be sent to the police department.
In this demo, we will illustrate the conveniences that start up when a person comes home. First are the lights, which illuminate the house as soon as the host triggers the motion detector. Next comes up the heating, as indicated by the orange LED. It will automatically reach pre-assigned temperature values prior to being left in energy-saving mode. We also have a red LED, which will light up only if the temperature sensor detects a fire. Now we will demonstrate the lockdown function, which our house also supports. In this case, any entry will be considered a break-in and therefore will trigger the alarm represented by the green LED.